use of this table method. So table method is simpler. 150 to 50 is 60. CP is 5. Again 5 into 60 is 300. So 300 is delta H start from 300. Then again 150 to 110, it's 150 minus 110, you will get 40. So what is the summation of CP here? 16 plus 5. 16 plus 5. Okay. And 150 to 110. So it becomes 840 or 880. You can calculate it. I did not know the exact value. I think 880 is here. Okay. 880. So 880 plus 300, you will get 1180 kind of thing. Please check the calculation, because I did not check the calculation accordingly. Okay, so 230 minus 150, again 80 is there, so 80 multiplied by 5, it's a 400, and total delta H should be 1540. Have a look. 80 is there, so they check here for 40. I don't know, 16 plus 5 multiplied by 150 minus 110, it becomes 840 or 880, I don't know. Let's check the calculation. Now we'll plot here T versus again delta H. Again another graph you have to plot. Cold stream curve. Cold stream curve. So here start with the 0 again. So 0 for 60 degrees Celsius, then 300 for 50, 0 for 0, and 300 is for 50 degrees Celsius, 110 for 110, then 1540 for 150 kind of thing. So you must draw these points, 3 points, you will get cold composite curve. Okay, once you finish this hot stream curve as well as cold stream curve, you did not get this stream curve data unless and until if you don't have graph, because you must have graph, and then practicing multiple problems. If you have two hot stream, one stream, or two cold stream, you must draw these lines, merge it, cold stream and hot stream. Now merge both curve, hot and cold curves, in such a way that cold stream move towards the hot stream curve should match delta T minimum 10 degrees Celsius. Now in the last web session, I have told you you have to merge two curves. That is nothing but this hot stream curve and this cold stream curve. So in such a way that you have to move this cold stream curve downward direction. You have to move the cold stream curve downward direction by keeping delta T minimum is 10 degrees Celsius. The significance of delta T minimum I will discuss later, but you have to keep the delta T minimum is 10 degrees Celsius. So there are two curves are there. So one is the cold composite curve, second is the hot composite curve. So where is the closer point in the two curve, there is a closed section is there, that is nothing but my pinch point. Have a look at the pinch point is there, the pinch point. So this pinch point, it occurs at where my two curves much closer to each other, that is my pinch point. So at the below point, at the pinch, at the below point at the pinch is nothing but the below of the pinch, below pinch. This section is nothing but below pinch. And what about this section? This section is the above pinch. This section is above pinch. So you will get this graph and significance of this graph by the next diagram easily. Have a look. There's a hot utility is there. So above the pinch, you will get the hot utility. How it comes? Cause your hot stream start from this line and cold stream start from this line. So there is a margin between these two curves is nothing but hot utility. So hot utility, according to our problem statement, have a look, is nothing but Q steam 100 kilowatt. Have a look here. Okay, there is a two margin between this hot stream and cold stream is nothing but hot utility, that is Q stream, that is 100 kilowatt. So that is nothing but I will provide one heater or multiple heater, but my heat duty must be 100 kilowatt. Doesn't matter, I can use two heater. I can use two heater. How it? So first heater is for 50 kilowatt, second heater is 50 kilowatt. Or I can use four heater for 25 kilowatt each, right? But my Q steam requirement is only 100 kilowatt. So I can use heater is nothing but heat exchanger. Okay, but providing the how much heat? Only 100 kilowatt. Doesn't matter, you can use many heaters, but keeping the heat duty is 100 kilowatt. Okay, so that is nothing but providing the hot utility externally, providing the heater externally. External heater you have to provide in the process flow diagram. Okay, so where you have to fix, that is nothing but the task of grid diagram. That is the task of grid diagram, we'll tell you later on. Then this is the part of heater. Now what about the cooler? So here the bottom section, there is a again margin between the cold stream and hot stream. Have a look in this diagram, hot stream and cold stream. There's a margin between, there's a difference between hot stream and cold stream here. Okay, at the starting section, this indicates as the cold utility is nothing but cooler. So here, according to our problem statement, so QCW is 300. So I can use multiple cooler, but by keeping the heat duty is 300 kilowatt. So I can use two cooler 150 to 150, or I can use three cooler 100. Okay, so that is cooler is nothing but providing the external cooler in the process flow diagram. External providing the cooler. Okay, so internal part of this curve is nothing but internal part. Have a look. Internal part of this curve is nothing but integrated region. Have a look, integrated region. So this much of heat integration you have, you can save. You can save. So how much energy you can save is around 1600. How much energy you can save here? 1600. Okay, so delta T minimum, it depends on fluid service. I will provide one more slide so that there is another example is there. So we'll start with the another example. At least some understanding must be needed because graphical technique it's too hectic to solve, and there is a large scale depending on your scale, and there are too many errors in the graphical section, but you will get at least trial and error kind of hot utility and cold utility requirement. Okay, so here you can easily point out the pinch temperature, so you can easily get the below the pinch, above the pinch. Again there are rules, there are certain rules are there, you did not provide the heat above the pinch or below the pinch kind of thing, or you did not provide the heat across the pinch.